Hey guys, welcome to the part 2 of the CCNA remote meetup for the NYC Cisco Networkers meetup group. And this is actually going to be a re-recording of what I did yesterday. Was doing a test run and things didn't come out the way I thought they were going to come out, so I'm just going to do this one more time here. And also, I even forgot to do my little commercial blurb in the beginning. So in case, if you guys are finding this video via YouTube, be sure to definitely check out the nycnetworkers.com site for the lab topology right here, the .NET file that I'm going to be using. Go ahead and go to Labs and go to CCNA Labs, and you're going to want to go to the part 2. And there's a list of the .NET file plus the PDF that we're going to be using here today. Also, normally I would show you our meetup site, but the past couple days meetup.com has been under like a DOS attack, so I have not been able to get to the site. It's been like up and down intermittently. So unfortunately, I would show you that, but you know, the next best thing I could do is if I go to my home page. I kind of have like a screenshot here. That's kind of what the page looks like. But hopefully, if they get this site up and working, you know, definitely check out our meetup.com page. The links are on the bottom. So yeah, so let's just jump right into this. So this is our topology here. I'm going to be using VPCS for our hosts. I already have that pre-configured, and that's actually also included in the .NET file. So if you have any questions about that, Keith Barker has a good video series about that over at CBT Nuggets, or you can just drop me a line and I'll try to help you out with that. Also, building on what we did with part 1, we have a router 5 here now included. So part of the prerequisites is assuming that you have everything cabled correctly. If you're using my .NET file that's already there, cabled properly, and assigning these IP addresses to router 5, router 4, and router 3, since that is going to be new connections that we didn't have before. Okay. Also, if you are picking up from the part 2, or at least part 1, make sure that one of the first things we'll do here is turn off DHCP and hardcode. I know originally we were doing, I believe, router 3 to router 2. Router 2 was being our DHCP server. So just to kind of get that out the way, take out that IP DHCP command and put in the static IP again. Next up, let's configure routers 3, 4, and 5 so that they can ping the closest routers as their default gateway. So for that, I kind of did that already, just to kind of save some time here. Actually, no, this is not it. 3, 4, and 5. So if you do a show IP interface brief, I can see here that I have some sub interfaces. When you guys are actually doing this, if you guys are doing this from scratch, make sure that the connections on the switch are actually configured properly, and you have them going to the right port, because I spent a good maybe like an hour or two just like troubleshooting stuff when it turned out to be just the cables are wrong on here. So we're just going to be doing the router on a stick or sub interfaces here. This F20 is going to be going into our trunk port on the switch here, and then we have VLANs 10, 20, and 30. So just to make things easy, I just create the sub interfaces using 10, 20, and 30. And if you look back at the prerequisites, 10, 20, and 30 are in VLANs 10, .10, .20, and .30, just to make it very simple for us to kind of eyeball. Okay, so if you guys want to see that configuration, the only thing you have to do on the parent interface or on the main interface is put a no IP address. But for the actual sub interfaces, when you type that in, and I can even show you that syntax, you can pick any number. So if you want to put 50 here and then put encapsulation .1Q10, that's still going to work. It's just it makes it more confusing for you, because then you kind of have to second guess yourself what you put in there. So we're going to say encapsulation .1Q, and you also, if you want, you can put in ISL, but we're not going to do that here. And then pick the VLAN. So of course, when you guys are doing this, it's more, as I mentioned during the last meetup, it's more repetition. If you guys do this for VLANs 10, 20, and 30, rinse and repeat for VLANs 5, 4, 6, and 7. It's pretty much very similar configuration. Sharp it in brief. I picked 60.1, 70.1, 10.1, 20.1 as a default gateway. And for the PCs, if I come here to my VPCS, I just picked a .10. So .10, .10, .20, .10, 30.10, 4.10, etc., etc. Okay. Let's see if I have it here. I do. The only thing is I have to do a no shut on the parent interface. Notice you have to do it on the parent interface. If you guys try to do a no shut on the sub interface, it's still not going to turn it up. It has to be done on the physical, not the logical. Okay. And we can actually test these pings a couple different ways. Where am I right now? 4, 5. So right now I'm on PC4, so I'll do okay, the first one timed out, but it seems to ping out fine. Let me go to PC6, which is on router 4. Let me try to ping that guy. And we got pings. So I'm pretty sure we got everything working fine here. Alright. Once we get full connectivity, adjust the NAT ACL that we created on router 2 to allow for the host to be able to ping the Verizon router, or basically to get out to our internet. So if we go back to our NAT router, 2 changes that I did here. Now, because now on part 2 here, we have 2 interfaces that are going to the inside. Before, we just had it set to 00 as the inside, but you can actually specify multiple inside interfaces, which is perfectly fine. So if I do a show run, you can see here that I got 00. I have my IPNet inside, and also for my 01, I also have an IPNet inside. So that's not going to break anything. That's completely fine. That will still work. You could even put IPNet inside on sub interfaces too if you wanted, if you had that set up. And it'll still work. Our NAT command here is still the same. The only difference I did was for the access list. Well, I just did a permit any, so this way it just catches everything that's in our internal network to go out. Normally though, just to give you guys some practice with NAT ACLs, try to do this on a per network basis. So you could do it for all the internal VLANs. VLANs 10 to 70, and also for the IPs that we have between the subnets that we have between the routers. But just in the interest of time, I'm just going to blow past that since we kind of talked about that already in part 1. So I can test this and verify this. I can ping 1111, which I tested out already. It works out fine. And even better, if you come here, you can see that this is actually incrementing my access list, so I know it's working. Let me come to this guy. Can I ping 111? Yep, and even my PC here can ping 111. I'm just allowing everything to come through, so that works fine. Okay. Once we achieve full connectivity, let's mess more with the IGPs. Let's just make sure we're not using. Don't let our bosses know that we're doing this here for our company network here. So let's start by assigning RIP version 2 everywhere and advertise the networks and ensure everybody can ping everyone. So this is actually interesting because somebody from the part 1 suggested that we use OSPF internally. So if I filter for a section router, I can see that I already have I only have OSPF running here. So one interesting thing we can see here that I did yesterday is that normally, or at least I haven't done it really normally, having admin distances fighting for each other, or if I put the same command information in here, I'll do router RIP version 2, no auto. That's almost like a knee-jerk reaction. Anytime you're doing router RIP, let's blast with that we know everybody here. And just to make this faster, I'll just do a copy and paste and put this guy everywhere. Okay, so I can go from, let's take a look at the routing table, show IP route, see what we got here. So routing table a little long, but we can only see here OSPF routes. If I try to if I filter this command for RIP, you can see that I'm not seeing any kind of RIP routes. Now I mentioned last night, how come we're not seeing any RIP routes here? Now, as you guys may know, we have something called administrative distance, or AD, that could stop this from happening, and in fact this is stopping this from happening. So a quick Google search for admin distances, Cisco admin distance. You can see here this chart. Now if you guys are going for the MP, this is definitely something that you practically need to know by heart. At least EI, GRP, BGP, OSPF, and RIP, especially for interviews. They kind of like to ask those kind of questions, like what's the AD of OSPF, or if I learn the same route from 2 different IGPs, which one's going to win, kind of questions. So we can see here that lower is better. Connected interface is 0. That's the best you can do. So if I'm getting 2 routes, one from OSPF and one from RIP, you can see that OSPF has a lower AD of 110 versus 120. So you can see here that our OSPF route is winning here. Now, one thing that we can do, or that we did do yesterday to fix this, so let's say for whatever reason we want RIP to be the winner. We can change the distance to 100 here. And note, this has to be done on all the routers. This is almost like changing the metrics in EI GRP. This just has to be done everywhere. And note that you're not going to see anything on here yet. So the OSPF route is going to stay in there because that's still active. It hasn't died down yet, so it's not. In a way, it's kind of preemptive, but it's not, because just because there is a better AD, it appears that in my routing table here, I'm not seeing that. So I can do a show RIP database. I am learning those routes, in fact. You can see that here in the database here, which fortunately for version 12.2, which is what GNS is running here right now, or 12.4, RIP doesn't have that many bells and whistles. Once you get to version 15 or Nexus, you can see like the neighbor tables and all that kind of good stuff. But there we go. So they finally timed out, or the RIP routes advertised that every 30 seconds and replaced the router heard an update from RIP saying that, hey, I have an AD of 100, and you can see that here. RIP has an AD of 100 versus 110, which we had up here before. So I'm going to put that in my routing table here. So they kind of do fight for each other in a way. It is preemptive. It's just that it's not going to happen instantly. You have to wait for it either to be advertised or for the old route to time out or age out. Okay. All right, so let's jump into here. That was a little bit extra. Maybe I should put that in here to the PDF. So make it so that router 3 and router 5 only accept updates from each other if the updates are encrypted. So let's go to 3. Now, this is something that I forgot one command yesterday, and RIP and EIGP are very similar. So we're going to actually have to specify a keychain, and then specify that keychain on a per interface basis. So let's do a keychain. Let's call it meetup. Key 1 we'll call keystring Cisco. We'll keep it simple. This is the same exact thing that you would do with EIGRP, nothing different here. Then let's go to the interface level, because we're going to apply this keychain to the interface. Neighbor. I want the interface for router 5. IP RIP authentication keychain, and I want meetup. I think that's it. Yeah, meetup. So I could do a fortunately, there's really no way to verify show commands to verify this. The only thing you could do is a debug IP RIP. And this is going to be chatty because I have another interface here. I want something that says RIP receipt update on 01. My fast internet 01. You know, let me do this. Let me kill that interface. Or even better, just to test this out, I can kill both interfaces here. So I start from fresh. Let me just turn on my debugging here. So it should be empty right now. Okay. Okay. So let's turn him back on only for this one because I don't want to hear the noise from 00. So do no shut here. I'll probably learn some OSPF stuff in here, but you know what, even better, let's turn off OSPF because I don't want to hear that noise either. Just want to prove a point here. Okay, I got nervous for a second there. I paused the video for about a minute or two because I was, as you guys saw, I was getting updates here. I'm like, wait a minute, what did I do here? Back on router 3. Where am I? I specified a space here, that invisible space. So when I specify meetup space did not exist. So I retyped it out again. This time I made sure that I where am I? Yeah, I retyped this out again just to make sure that I wasn't getting that missing space over here. Once I did put that in here, I ran over to router 5, and now I'm seeing with the debug, I'm seeing what I'm looking to see. I received a v2 packet from router 3, but it's an invalid authentication. So that's what I'm looking to see. Everything in here is like just old config. So let me do on the other side here. Let me do a key chain meetup. Make sure I don't put a space there. Key 1, password, key string, Cisco, and go down to the interface, IP RIP, authentication. This is like keychain meetup. And now if we do another debug RIP, IP RIP, let's see what we get. Yep, and that's what I'm looking for here. Let me just do a URL to kill this. We see the packet with text authentication, which is true. I did call it Cisco. Probably not best. I probably should use like MD5 or something. But the fact is that I'm not seeing this. I'm not seeing the invalid packet type or invalid authentication. It took. So that's what I want to see. Let's see. All right, adjust the timer so that it sends out every 10 seconds instead of every 30 seconds between 3 and 4. This is a command that you could do globally. So if you do router RIP, where's the command? There's not that many commands in RIP, which is kind of nice. You do timers, basic, and this will be something that you do change the timers globally. But in this case, we don't want to do that. I want to do it for the interface. So router 4 is on 0, 1. Same command, timers, basic. Or should be timers, basic. IP RIP. Advertise. So 10 seconds. You want to do? And let's do the same on this side too. IP RIP, advertise 10. Now, because this isn't global, if I do protocol, you're not going to see that here. It's still going to say sending updates every 30 seconds. The next one's doing 10. So one way that you can change that globally, as we saw already, and this is only local, was the timers basic. But this is going to ask you for everything. So it's going to ask you for the send, next due, invalid, hold time. So you can go do everything here, but I'm not going to go that detailed. Just know that you know, you do have those options there. See here, is it possible to view the RIP neighborship table or the RIP database table? Fortunately, with regular iOS, you can't. If you do show RIP question mark, there's nothing. If you do show IP RIP, you can only see the database, which chances are you're probably not even going to go into this, even at the iLab or even in production. You wouldn't even be in this situation in the first place. But not that much in here. But if you guys do mess with version 15, you do have a chance to take a look at all that stuff. See, force all RIP routers to accept and send only version 2. So this is something that you can do globally or per interface, but do a question mark here. Where am I looking? Version. I think it's only per. Oh, you know what? No, I'm sorry. This is per interface. Because if you do show up your protocol, you can see here this is on a per interface basis. So you can do if you go under 0, 0, you can do question mark. Oh no. IP RIP, and you can see here the send and receive. So what type of versions you want to send or receive. So we said we want to accept and send only version 2. So receive version 1 or 2. So you can say 1 or 2 here, or you can hard code to say only 1, or you can say 2, or 1 and 2. It's up to you how you want to do it. But in this case, we just want to do only 2, which is the default anyway. But just try to show you something different, I'll do 1 and 2. And then for the send, I want to send version 1 and 2 packets between each other. So if I do a show IP pro, you can see here in the column now, I'm saying that for this particular interface, I want to send version 1 and version 2. Okay. Split horizon issue in this topology, the way I design this here, I don't think so, because every router here has at least 2 links to get to everywhere else, so I would not be receiving an update receiving an update that I heard from already. So in this case, no, the way I designed this network, but it's just good to know for EIGRP, RIP, and even BGP. Split horizon could be an issue, so when you guys are making up your own labs, just keep that in the back of your heads. Next up, for security reasons, management wants you to hardcode the RIP neighbors. So this is the same way that we do it in OSPF and EIGRP. You go down to the router RIP process and just specify the neighbor. So let's say, you could do 3333 if you want to. Now, in our situation, since it's broadcasting everything out anyway, not going to be much of a problem. It's going to this command's not going to change anything. But if you're on a older medium that doesn't support broadcast or multicast and only does unicast, then you would put this command in here to send out those updates. Okay. Mess around with the auto summary command. What does this change anything on the routing table? So if I go to everybody and turn back on auto summary, we'll just do anything from my table here. And RIP is still waiting because I changed the distance to 100. In our case, this may not be a problem. At least when I did this yesterday, it wasn't a problem. We might have to wait for some of these routes to time out. I'm just gonna wait a few minutes, so I'll pause the video and wait a few minutes, see if it does anything. You know what I'm gonna do actually, guys? Just to speed this up, I'm just gonna shut down, instead of waiting, I'm just shut down those two interfaces on router 5. Now that I have auto summary turned on, we should hopefully see if there's any difference. Alright, so that's the routing table that we had up there before. Let's take a look and see how it looks now. And it looks a little smaller. Let's see, let's ping my hosts. Let's see if I can get to all of them. Okay, that works. I mean, at the end of the day, that's the most important part. Can I get to my hosts? Seems to be working fine. It seems to be working fine, and this command stands out of why I could ping my hosts here. And let's actually see if that's the case. So, show IP route 10.10. I'm knowing this via RIP, via 35003. So I do have an entry for it. So once again, I guess it looks like the way I designed the environment here, it is working fine. Let's see if I can get out to the internet. Yeah, that works out fine too. So it looks like even in our situation, turning on auto summary did not do anything. I guess because I made sure everybody was unique in this case. Okay, finally, let's do some debug commands here. Now, it's not that many debugs you can do here. You can either turn all of them on, or you have 3 other choices here. So it's just good to know that, especially when, even for like the labs that we have over here, if you guys want to take some time and try the different events here, or even do all of them, you could do debug, not even all, just hit enter. And I mean, even taking a look at this for 5 minutes, you can see here what you should normally be seeing when RIP is working fine. And this actually especially helps for the exam as well, because chances are you're not going to be using RIP for any production environment, but at least in the testing room, and they show you like a little snippet of the console and be like, okay, what does this command show you? You'll at least know where they got that command from, or what this should look like. So I'm turning that thing off. Next up, let's move on to OSPF. Okay, so for that, let me kill RIP everywhere. And actually I have a notepad here with, oh no, this is my multicast stuff. Actually, I did have a notepad here. I had one before earlier. My OSPF stuff here, so I'm going to start from scratch. I think I turned it off some of them. Okay, that one has everybody. Okay, I'll have to put it on here. Of course, normally you would never do the old 255, but in this, or the wildcard here, that would just shoot everybody. But oops, we're not looking to do neighbor shifts at this point. I mean, that's pretty basic. I just want to show you guys a little bit more advanced stuff that you can do with OSPF. Okay, BDRs are there. They're in full state. Okay. Therefore, all the neighbors are up. Even better, what I can do is ping 1111, and I can. Let's take a look at that routing table. I can see, yeah, you got all OSPF in there. Router 2 actually should have the default information originate command, which is in there, so that's good. That's how we're getting our default route. Now, why was the DR chosen, or designated router chosen over the others? Now, in our situation here, the DR doesn't really make too much of a difference because we're all on a point-to-point links. So router 2 to router 3 is one segment or one point-to-point. Router 2 to router 4 is another point-to-point. The time when DRs come in play, which I demoed out yesterday, but in the interest of time, DRs is more of a MP topic. But that would be a situation where we had, let's say, something like this. So let's say this little bubble here, we turned all three of these routers on. One of them would be the DR, or the designated router, the guy who's in charge of sending updates for that particular segment, because these all guys can see each other, and then on a point-to-point, there's no like boundary. All three can see each other. So one will be OSPF will have one as a designated router to send all the updates for that particular segment. We'll also have a BDR, which we saw here. This is a BDR. So if you go to the other side of router 4 and I do a show IP OSPF neighbor, you can see there's a DR here, a BDR. And we're not going to see it in this situation in our lab here because everything's point-to-point. But if we had a third router, that guy would be known as a DR other, or designated another designated router. which we're not going to see here because everything's point to point, like I mentioned, but he will be almost like the standby. Okay. So in this case, why was it chosen over the others? Generally, it's the highest IP address. So if you take a look at 4, let's see, 4 and 5 are here. Be our other. Let's jump to 5. So you can see here that 4444 is the DR, and 555 yeah, the DR. 555 is the state is the backup here. So for security reasons, hardcode the neighborships and make sure that you use MD5 authentication. So this is really, really simple. This is almost actually even easier in some sense than what we had originally with OSPF. So if I want to do, and I'm only going to do this once, just to save some time here, but we'll do IP, no, IP OSPF authentication, and I'll just use message digest. And that should kill my neighborship to router, who did I do this under? 00. So router 3 should die. So you can see that the timer is starting to go down. It was 25 seconds, 22 seconds, 17 seconds, 11. So that's basically going to count all the way down till the dead timer expires. So in order to fix that, now once again, in our case, if you maybe unless you play with frame relay over OSPF, but in our case, if I hard code it, so let's say neighbor, .333. I mean, that's still not going to fix the situation here because we're sending encryption or the message digest. So let me go to the same side here. Authentication message digest. And I can also put a neighbor here too, but that's not really going to do much since we're on a broadcast network here, but I can go ahead and put it in there just to hard code it. And then you can see already it came back up. Now that was per link, but you could also do it for authentication. You could do it for the whole entire area. So you could even do a blanket statement too. So if I go to router 4 and you go under OSPF, you can do what was it? IP authentication. Oh yeah, area 0, because we're talking about area 0 in this case. Authentication message digest, and that'll turn on for all your OSPF interfaces. That's too much brief. So all the OSPF interfaces will have the message digest turned on for them, and then you could verify that. You could do show IP OSPF interface, let's say 01. You can see here that message digest is authentication's enabled. And I got some neighbors dying because I didn't do it for everybody on the other routers, so let me go ahead and do that. So that should take care of everything. Everything should come back up after that. Okay, next up, for traffic to the fifth, and I actually got to reword this. what I want to say here, for traffic from the VLAN 50 to get to, and I could say, let's say VLAN 10 or VLAN 30 or anybody here, instead of having it take, I mean, because right now it's taking router 5 to router 3 and comes up to the VLAN, I want actually, for whatever reason, I want to take router 4 as part of its path. Because if I do a trace route right now, and I should be able to do that on, should be able to do it on here. So if I go to router VPCS 5, I should be able to do a trace 192.168, let's say 10.10. So you can see right now it's hitting 50.1, which is router 5, then jumps to router 3 interface F01, 1/0, and then it finally gets to 10.10. So if I wanted to actually take a different path, there's two ways you can do this, or at least at the NA/MP level, there's two ways you could pretty much do this. One way would be to mess with the bandwidth, so I can make the bandwidth lower than 100 megabits per second, so I can say like 10, which probably it would work, but I want to try a different command. IP OSPF cost. I believe the cost is 10 per interface, so I can make this. I don't know. Let's say I think I tried 100. Let me see how that works. So we try IP OSPF interface. Yeah, the cost is now 100. But by default, like if I take a look at 00, by default that cost is 10. So let's try that now. Okay, so it looks like lower is better. I can see here that I have a new hop added to my trace route. I'm taking me 4 hops instead of 3. So I'm going through 45004, which is router 4, which finally jumps to router 3, which finally jumps to router 4. So that's actually what I'm looking for. Perfect. This command I probably should have put more in the beginning. How can you view the neighbor table and database table? That's a command I've been doing this whole time. Show IP OSPF neighbor. I can see my neighbors. Also show IP OSPF interface brief. I can take a look at all the interfaces that have OSPF enabled, and IP OSPF database, which shows me the details of my, I guess you could say backup routes, or all the LSAs that I've received on this router. Which maybe if I put like an NP series together, I'll go into more details on that stuff. Next up, hardcode router ID for each router using the router's local interface, loopback interface. This is a very simple command, just router ID. By default, if you don't specify it, it will pull, if you already have it configured, the loopback, highest loopback IP. Or if there's no loopback IP, it'll pull the interface. But we can hardcode it just to be on the safe side. Okay. Now in this case, it's not going to break anything because it's already using that. When you show up OPS neighbor, you can see the neighbor ID here is already set to the loopback. That's just by default. But if for whatever reason you want to choose another one that's not, maybe you have multiple loopbacks or something, you can pick which one you want OSPF to use. All right, a few more here. Change the hello interval priority and transit delay, and what timers need to be the same for neighbors to stay up. What timers do not need to be the same for timers to stay up. So this is more of like an exploratory lab here, or objective. So I'm not going to try all the different combinations. That'll make this video too long. So on your guys' own time, go on a per interface basis and just try it out. So I can go to 00. which is going to router 3. For me to sit here and try all the combinations, we'll be here all day, but I can change the hello to, let's say, 5, and you can see if that breaks anything here. Go into router 3. Once you get into the teens, you know that that hello change that I just did probably broke the neighborship here. So I want to take this here, and it's basically setting the hello frequencies, or it's kind of like a keep alive between the two. It's probably going to break it. So let me go to 0, 0. Put that there, and this should jump back. It already died, and just came back up. Okay, so we know that broke it. Let's try IP OSPF Priority. Let's put like 33, because that sounds like a weird number. You can see here, if you want to check what the priority is, you can do a show IP OSPF interface. By default, it's a 1. And I believe lowest is better. The lower the priority is used to find out who's going to be the designated router for a segment. So that should not break anything. So let's do, we did that under 0, 0. 0, 0 is router 3. And does that break anything? Should not. And it's not. You can see it went from 16 and jumped up to 18. So that's not breaking anything. So we can leave that just on one side of the neighborship. Let's play with the transit delay. Does that break anything? We'll go back to our guinea pig 0, 0. Transmit delay. Let's choose another odd number like 3, 2, 1. And you can see here that the transmit delay is 1 second. 1 second by default. But if I do to verify that, I can see that transmit delay has been changed to 131 seconds. Will that break anything? And it doesn't. The number just jumped up from 15 to 18. So transmit delay will not break anything here. And I mean, there's a bunch of other commands that you guys can play with. I just picked these 3. But you have like dead interval, flood reduction. Let's see what else we got here. Retransmit delay. So there's a couple other ones that I didn't put in here. But as I mentioned, get comfortable with it. Get familiar with the different timers that we have here, and see what breaks it. I mean, generally the hello and dead timers generally break neighborships, but I mean, give it a try on your time and see it for yourself. You know, don't trust me or don't trust the book. You know, find out for yourself. Alright, next up, we knew this was going to happen. Let's put router 2 and router 3 in area 0, and router 4 and 5 into area 1. Now, this was all the show commands we've used so far, and note the differences on the routing table, OSPF database, and ensure all hosts can still ping each other. So, for this, I'm going to put this in here. So we want so 4 or 5 are going to be area 1. So we're going to have 2. Actually, these 3 routers would be known as ABR routers because they're connected. Router 3 is going to be 1 going to routers 5 and 4, and 4 and 4 or 5 will be 2 different ways to get to router 3. So said 2 and 3's area. Okay, so we don't have to touch. We don't have to touch that. But this all zeros is probably not going to work for us here. So let's get rid of that. Oh. Let me do show update interface so I know who's going to be in what area. I can safely say these guys are going to be in area 0. Loop back, I'll keep it in area 0 too. Zero zero will also be in area 0. But 1/0 and 0/1 will not. This will be my area 2. I mean area 1. And yeah, we're gonna have problems. We'll fix that area in a second. 35003 is gonna be area 1. That's because we don't have any links here to join. So let's jump to 4. That's the full command. Let's start from the top bottom. 0 0 will be in area 1. This guy will be in area 0. This guy will be in area 1. In this case, I can clump these two together to be in area 1. This guy I want to be in area 1. Okay, let's go to 5. Let's fix up the rest of it. These guys will be my area 1 and my area 1. And something's not working here. Received invalid packet from backline unless you virtually but not found for it. Okay. I wrote a 5 here. Wrote a 5. As you know, guys, let me pause this because I'm just gonna make sure I can sync everything up here. and when it's ready, I'll come right back. Okay, I'm back, guys. Actually, my landlord just came down. We just had a we just had a good conversation here. So we got everybody up here. Cleaned up some of my fat fingering, and strip your OSPF neighbor. All right. So the key thing is in here, guys. So as I said, routers 4 and 5 interfaces are going to be off of area 1, and routers 2 and 3 are going to be interfaces are going to be off of area 0. And then you could kind of the way I kind of have it set up here is a little weird with the links. So you can kind of pick which links you want between 3 and 5, 3 and 4, and 2 and 4. You can just make it your own preference, you know, if you want them in area 0 or area 1. As long as you don't start getting this stuff here, then it becomes a hassle. So let's see what happens. So let's do a couple show commands and see what we got. I already did some of the show IP OSPF neighbor, so that looks like it's fine. Let's make sure I can. More importantly, you want to take a look at the database. You can see this actually got a lot longer than what it was before. Biggest thing here, as you can see here, so you can see your LSA 1, 2, and 3 here. The biggest thing here is your summary. And your type 5, you can see here. That's changed. And also, if you take a look at the routing table, you can see some inter-area routes, or IA. And I don't think CCNA goes into inter-area routes, but this is like a good stepping stone to get to the MP stuff. Basically, and I'm trying. Where's that flag? Here we go. Inter-area route. Basically, it's saying that I'm learning this through an autonomous border or autonomous border router. So he's not in your area 1. He's in a different, or area 0, or whatever area you're in. He's in a different area. But I can try pinging him, like 555, for example. I can still get there. It's just that the router is telling you that this guy is in a different autonomous system because I put him. He's the loopback of router 5, and we're on 3. So I'm just saying he's in a different area. Right now, it's still not too much of an issue because it's pretty. We're at the NA level, so I'm not gonna go too crazy into it. But it's good to start getting familiar with seeing these flags here, and I can still ping them too, so that's good. Finally, let's do a couple debug commands, and then I'll wrap this up because I didn't do EIGRP with doing the webinar with the guys. Here you can see we have a couple more options that we did with RIP. We can see the adjacencies, some events, some hellos. Some packets, so we could even do adjacencies, which you're probably not going to see anything because nothing's coming up right now, but I can see, oh, look at that, you can see our message digest going through. I can see some, let's turn that off because I don't want to see that over and over and over again. Let's do some events. I'm receiving a hello. Looks like the key got stuck back in there again. Sent a hello. Received a hello. Let's see what else we have here. We can do. There's another one that was here that I want to do. Packet. This probably will be chatty. Couple of DLTs I can see going back and forth. Also, unlike RIP, if you do a debug, unlike RIP, you actually can do. Actually, no, you can't. Never mind. Debug OSPF. I thought you can actually do debug question mark, but it looks like you only have these commands here. So this is pretty much like your tool set here in case things aren't working properly. Try a couple of these guys out. I was thinking maybe you can kind of nest these commands, but it looks like you cannot. Yeah, you can only do one at a time. But the good thing is you can actually stack them. So you can type SPF. You can kind of type commands over and over, and you can get a combination of them. So if you want to, you could even copy and paste this whole thing into Notepad and just get familiar with what you're seeing here. Okay. And that is it for me, guys. Thanks for hanging in there. If you guys have seen this for the whole thing, for about the past hour or so. As always, check up our meetup page whenever they get it working. In the meantime, you can take a look at nyscnetworkers.com. The .NET files are there. And I'll see you guys for part 3 in April.